Alright, so we will continue looking at balancing equations. Just wanted to have a couple different examples just to kind of look through. We'll do a couple simpler ones, or at least one simpler one and then one a little more complicated. So let's look at the synthesis of ammonia from nitrogen gas and hydrogen gas. So that is nitrogen gas plus hydrogen gas makes ammonia. So what we can do, we look at the elements that we have, and so we see we've got N's, which are nitrogen, we've got H's, and in this case, that's it, just N's and H's. So this one's actually a bit more simple. And we can set up just kind of a graphical way to look at this. And this will actually mostly be it. So we start off, we go through here, so we'll start with N2. We've got 2 nitrogen and 0 hydrogen. Over here, H2, we've got 0 N's and 2 H's. And then finally, over here, for ammonia, we have 1 and 3 hydrogens. So, easiest place to start if we want to try and balance these out is right here with our nitrogen. We've got 2 over here on the left and 1 here on the right. So the easiest way to get this equal to this is that we put a 2 in front, and so this means that everything in here gets multiplied by 2. So 1 times 2 equals 2. 3 times 2 equals 6. So on the left side, we have 2 nitrogen. On the right side, we now have 2 nitrogen. But our hydrogens are now out of balance, because we've got 2 on the left side and 6 on the left side, or 6 on the right side. So how can we make these 2 equal? Well, if we put a 3 here, which gets multiplied by this, 2 times 3 equals 6. So now with N2, 3 H2s, that balances to having 2 NH3s. So here's our balanced equation. If we were to rewrite it, N2 plus 3 H2, and then on the right side, 2 NH3. So balanced equation for the synthesis of ammonia. So we'll do one more real quick. Let's look at we'll do the combustion of methane. So methane, CH4, combustion means we're using oxygen. And if it's combustion, that means we make carbon dioxide and water. So combustion of methane. So what do we have here? We've got C's, we've got H's, and we've got O's. And that's it. So we can make our table here to kind of work through. Alright, so to start off, again, we look here, and we're just looking at how many of each we have. So, CH4, we've got 1 carbon, 4 hydrogens, and 0 oxygen. O2, 0 carbons, 0 hydrogens, 2 oxygens. Over on the right side, carbon dioxide, 1 carbon, 0 hydrogens, and 2 oxygen. And finally for water, 0 carbon, 2 hydrogen, and 1 oxygen. So, we start off, well, it looks worked out. Carbons are already balanced to start. So, what will be the next thing we can look at? Probably the easiest would be our waters and our H's. So we've got 4 over here and 2 over here. So if we change that, so in order to get that to balance, we want to put a 2 in here, because that 2 was multiplied by everything after it. So 2 times 2 times 2. So 2 times 2 is equal to 4. 1 times 2 is equal to 2. So now, for carbon, 1 on the right side, 1 on the right side, 1 on the left. Hydrogen, 4 on the left, 4 on the right. Finally, for oxygen, we've got 0 plus 2, so that means we've got 2 over here. And on the right side, we've got 2 plus 2, because we add these together. So 4. So now, we've got too many oxygens on the right side compared to the left. So what can we change to this oxygen here to get it equal to 4? Equal to 2. And so 2 times 2 is equal to 4. So we've now got 4, which is equal to 2 plus 2. 4 equal to 4, and 1 equal to 1. So we have our balanced reaction of CH4 plus 2 O2. And on the right side, CO2 plus 2 H2O. And that is another example, balanced reaction for the combustion of methane.